chapter 1, like 1.6 or 1.7 was called parametric equations and inverses, which means some of this stuff might be familiar to you, or maybe you learned way too much since chapter 1 and you've forgotten all about parametric equations. But the reason that we come back and visit parametric equations is now that we know trig, we can do a lot more with parametric equations and graph really cool stuff, things. So basically a parametric equation throws in a third variable. So again, write this, maybe just listen to this part, and then you can start writing on the next page. I said that once already, but a whole lot of people are writing with me, I'm guessing. Maybe you didn't hear me the first time. Most equations, you have two variables. You have an x, that's a horizontal distance, and a y, which is a vertical distance. But what if you wanted to throw in a third variable, maybe to think about time? Like if I said, if I had y equals x squared, how long does it take to go from -2 to +2? We don't know how to do that unless we throw in a third variable, which is what we call the parameter. And so when you graph a parametric equation, it can still look like a normal equation. It just is written differently. And so that's the big part that we want to get used to. And also the cooler part than what we did in chapter 1 is we're going to use the graphing calculators to graph some awesome stuff. In this chapter, we're going to graph Rose curves, which are very exciting. They're like graphs that look like this. Ooh, we're going to graph some of stuff like that in this chapter. It's awesome. It's called a Rose curve. But yeah, we get to graph functions like that. And there's one on your homework today that's like this. There's an equation to get that graph. Isn't that awesome? You seem not impressed. The cool part, not so cool part, is in second hour today, they were not using their calculators correctly, so instead of getting graphs like this, they were just getting graphs like this. And they're like, oh, I think I did something wrong. So, we'll have to get to that part. So you don't have to write this down either. But why do we do this? Really the point of parametric equations are ways to represent things that are not functions. Most of what we have dealt with up until this point in math has been a function, right? It passes the vertical line test. Those graphs I just drew are not functions. They're crazy graphs. And so this allows us to write equations for those and graph them, especially with a calculator, very easily. And there are some applications of this with velocity and acceleration, physics stuff. We're not going to get into too many applications with them because we're just going to try to get the graphs of them and go from there. So, but that's why we do them, not just to torture you. Okay, this is where you need to start writing. This is kind of the definition of a parametric equation. I'll sort of be quiet maybe a little bit while you're writing this. I swear our class gets smaller every day. I know.
I haven't missed a day of school.
You're jinxing yourself.
In case anyone was
Except for you're going to miss next week to go on an English filter, I bet.
Yeah, but
what are we doing Thursday?
I don't know. It depends on when you get your test back.
oh my gosh, is that next week?
And yeah, it's the 24th, right? Yeah, it's next Thursday.
Because Thursday, I don't know what time we're going to be back. So,
Yeah, it's because this thing isn't running, and so when it's quiet, you can really hear everyone else a lot. Tomorrow the heat should be back on because it's going to snow, so. Oh, wait, it's going to snow?
yes.
It's supposed to get down to 28 tonight, and so because it's rainy, there's a chance that rain will turn to snow. But I'm very confident by the time we wake up in the morning, it'll already be back above freezing, and it'll just be wet. It'll just look wet when we get out, but it's supposed to maybe snow overnight.
But if it snows, and then it gets just, and then it's wet, and then it'll be cold.
Not good. Here's the big thing about parametric equations, and maybe once we do one, it'll maybe come back to you. I don't know. There's two equations for every parametric equation because they're in terms of t or some other variable. With trig, we like to use theta instead of t. But you have some function in terms of t that equals x, some function in terms of t that equals y, and this is just some vocab here. We call the graph that this makes a parametric curve. The equations are called parametric equations. The variable that's t or theta is called the parameter, and they say that the I is the parameter interval. In chapter 1 we did this, they always gave you an interval to graph, like graph from -2 to 2. I think in this one they just want you to graph like over the entire interval, like -infinity to infinity, so you can just put arrows on it. But sometimes they give you the actual interval to graph it. To sketch these, we're not going to throw in a third axis, like we're not doing like XYZ stuff. We're still going to graph on a normal XY plot, but you have to pick t values, and I think once we do one, it'll vaguely come back to you where you had to make a TXY chart, and then, oh, remember that? Oh, Colton, remember when you didn't talk in here and you're a nice, quiet, good boy,
Yes.
and not full of sass? I think so. I think you're to blame.
Maybe I'm like,
No, I just said
maybe that's rubbing off.
Only 33 more days of school after today.
that's 33 more that we have to come here.
That's not very many, kids. 33! I know, it's out of control. And you gotta think like 3 of those are finals, so that's 30. You gotta think a couple to 3 days of reviewing. Now we're down to 20s. So, you know, not that many more active days of learning, kids.
So weird. And we're getting
But
Wow.
then, once we get closer to like AP exams and stuff, people are like teachers are just gonna start cramming stuff into our heads.
where we're just
I'm not. You're not in my AP class.
sketch.
What, do you need me to go up? Oh my goodness. That's right, I'll write it over here. When you graph this, you have to pick t values, because notice t is in both of these equations, and remember that whatever t values you pick, you just plug them into the x and the y equation. You can pick whatever you want to get the graph. You don't have to graph a million of these on your paper, but just pick a few points until you get the shape. I think on this one I want to pick actually 5 points, just because I want you to see what's happening here.
Does it matter what point?
It doesn't matter. I usually try to pick small numbers so I don't have to make my graph very big. If I picked a point and I got a really big number, like bigger than 10, I probably wouldn't graph it, and I would just pick different numbers. And if I plug these numbers into the x equation, plugging in your t values, you're just squaring it and subtracting 2. So if I plug in -2, I get 4 minus 2, which is 2. If I plug in -1, I get 1 minus 2, which is -1. If I plug in 0, I get -2. If I plug in 1, I get -1. And if I plug in 2, I get 2 again, right? With me on that? And the y's are even easier on this one because it's just 3 times t, so I'm just going to multiply all of these by 3, so that's going to be -6, that's going to be -3, that's going to be 0, that's going to be 3, that's going to be 6. TXY chart. You with me on that? So why do we like parametric equations? Because we can graph things that we're not used to graphing so much by just making an XY chart. And now we don't graph t. These are the ordered pairs that we graph. And maybe if you graph these, you'll see the shape that you have graphed before. So at 2 on the x and -6, and at -1, I'm at -3, and at -2, I'm at 0, and at, oh, I screwed something up, didn't I? 2, -6, -1, -3, -2, 0.
Oh, you have the -1 too, so.
I have what? Oh, I have -1 written twice, don't I? What's wrong? This is not supposed to be this difficult, kids.
You went 1 instead of -1.
Yeah, it's supposed to be -1. Oh, thanks, kids. Whew. Too bad I don't know how to graph. That makes me feel better.
It's been a while.
It's been since second hour when I did the same exact problem. It's really hard to see the squares on this, and so I have to squint a lot to find my points. What kind of shape is that? Oh, it's a sideways parabola.
And it will
Just
go
a
vertical line.
arrow.
Not because the arrow is that.
Oh, yeah. Yeah, it is. I didn't think about that.
You graphed sideways parabolas before. Remember last year in Algebra 2 when you did conic sections? And you did sideways parabolas and ellipses and hyperbolas. This is not a function. So it's kind of a cool one to graph with, what's it called? Parametric equations, because it works out really well. If you tried to graph this on a graphing calculator, you can't just type in one equation and get this to graph, because you can only type in functions unless you're in parametric mode. And so this is why we like parametric equations. The other big thing that we want to do is we want to eliminate the parameter. Eliminate the parameter means write the equation with just x and y in it instead of t. And so let's go ahead and eliminate the parameter on this, and then I'll kind of write that out for you if you. I have it on the next slide here. Eliminate the parameter. Just means write it as one equation with just x and y, which means it's just our favorite friend substitution. Because if I have two equations that both have t in it, could I solve this for t and plug it in this equation, and then I'll have no more t's and only x's and y's? Yes? So if I was going to do this, I would say that y over 3 equals t. So I would just divide by 3 here, because isn't that easier to solve for t than the one that's squared? And then I'm just going to substitute that in for t right there, and look what I get. I get x equals, I'm going to go ahead and square all that. Y squared over 9, because it'd be y over 3 squared minus 2. I can show that step if you want. Y over 3 squared minus 2. And do you remember last year with conic sections, if you had x equals y squared instead of y equals x squared, it was always a parabola on its side? Okay. Anyway, it's what happens. Normally our parabolas open up or down, and it's x squared, right? If you see x squared in a problem, you're like, oh, it's a quadratic. It opens up, it opens down. If you see y squared instead of x, it's a parabola, but it opens side to side. It's not a function because the y is squared. Nothing? So if you need directions on eliminating the parameter, that's the directions. What we just said. If you feel like you know what it means to eliminate the parameter, you don't have to write all that down. But to eliminate the parameter means you have to solve for t or theta, because theta, sometimes we use theta, in one equation, substitute it in the other equation. And so here's what a lot of your homework is. It's not all going to be graphing it, but the directions are going to say eliminate the parameter and identify the graph, which means this is kind of a good review of, do you know when you see an equation what kind of graph that you get? If you don't know what kind of graph that you get, then you might have to make a graph. But if you know, then you just get to tell me what graph it is.
How do you like, what do you mean identify?
Well, like on the last one, if we wouldn't have actually graphed it already, if we would have solved that and solved that it was x equals y squared, like you'd say that's a parabola that opens on its side. And that's what they want you to recognize. And so we might have to write down some little notes to remind ourselves. If you got an equation that just was x and y and nothing squared or anything, what kind of graph would you have if you just had x and y in an equation? No squares, no cubes, no square roots, just x and y. What? Linear. It's just a line. If you had an x squared and not a y, it's a parabola that opens up and down. Right? Those are the kind of things that we want to know. So step 1, we want to solve this for t and plug in the other one. Which one looks easier to solve for? X or y? Not y, because what would you have to do to solve that? You have to take the square root, and what happens when you take the square root of an equation?
Oh, yeah, plus.
You get plus or minus, which means you'd have to sub in 2 different things. So don't take the square root of a problem in here. Bad news. So solve the top one. Don't square root. Add and subtract. Easier than square rooting. Because do you agree that I could say t equals x minus 2? And then could I just plug that in for t there, and I would get y equals x minus 2 And then second hour, they said, do I need to FOIL that out? You could, but as long as it's X and Y, and you can tell me what kind of graph it is, this is a perfect answer. What kind of graph is that going to be if you graphed it? Specifically opening which way? Up. Because if it's x squared and it's positive x squared, it opens up, right? If it's x squared and it's negative, it opens down. So I can say this is a parabola opening up. In second hour, Mason, who I don't even know why he asked, because he's not going to do his homework anyway, says, can I just write parabola with the arrow up sign? I'm okay with that. I know what that means.
Probably simple, but how do you know that?
I feel like you gotta know quadratics, right? Like you gotta know if you see y equals x squared, or you see that x is squared and y is not, you have to know that that's a quadratic, that's a parabola, and because it's positive, it opens up. So it's just like this. And if you see a y and a negative x squared, x is squared, y is not, then that's a parabola that opens down, right? You've been doing that since like algebra 1. You just gotta know it. What's the one that we don't do as often that shows up a lot now that it's parametric equations is what if it opens side to side? You got to recognize if y is squared and x is not, then that's the side to side one. So if you had x equals y squared, it's just like the last one that we did, it's always going to open to the positive side of the x-axis, so that one's going to open this way. But if it was x equals negative y squared, what's going to happen? It's going to open to the back. Okay? Again, if nothing's squared, it's just a line. So you might have one of those on your homework today. Don't overthink it. If nothing's squared in the problem, you just have a y and an x. That's a linear line. That's like slope-intercept form. If they're both squared, we'll talk about that in a minute. Let's do another one. Ooh, how about this one? It looks extra ugly. Which equation looks easier to solve for, the top one or the bottom one? Top one. Solve it for t, plug it in the other one. Again, the directions here are not to graph. The directions are to identify the graph. And this one is kind of tricky, which is why I put it on here, hoping that I can remind you what the graph looks like. Will pass. Right? So that's just y equals x plus 1 over x. That would be eliminating the parameter, which we've graphed before. You might not remember, but we have graphed those before. Does anybody remember what that graph's called? Colton remembers it has asymptotes. Or what it looks like. Or starts with the R, ends in the L. The parent graph kind of looks like this, where it has a horizontal and a vertical asymptote.
Radical.
The book calls this reciprocal function or rational function. I would accept either one of those. So, and it's not going to look exactly like that because this is actually has horizontal asymptote at 1, but rational is what we would call that one. That's probably the one that you, besides parabolas, lines, rationals, the other one they could throw in there, and then the new kind, like I was telling second hour, like some of these are the exact same notes I gave you in chapter 1. Just copied the same problem over because it's the same stuff. But why are we doing this again? And not just because you forgot about it, but because now we can throw trig stuff in and we can graph super cool graphs that we didn't graph in chapter 1. Okay, ready? Notice oh my gosh, hold. I thought you were falling. Eliminate the parameter and sketch the graph. Notice I changed t to theta. It's okay. Either one of those are okay to use there. I think your book tends to stick with T. I'm gonna do this one with you, and this is where you get mad about math and you say, this is stupid, how in the world am I supposed to know how to do this? Because I give you an example. How did I know how to do it the first time? Because there's examples in your book, like before the homework. I know you probably never looked back there, but there's a whole bunch of examples that work through problems and tell you how to do them. And that someday you're gonna go to college and take a math class, and they're gonna think that you look at your book. So I like to tell you that it's there. Sometimes they're gonna use you on sometimes they go into the graphic part way too much. But, this one's kind of hard to eliminate the parameter. That's why we gotta think outside the box here. Because if I just try to solve this, if I think about this as our t value, if I try to solve this for theta, we'd have to inverse cosine both sides, and that's just gonna get really ugly really quickly. The good news is that these are the same type of problem over and over again, and soon you'll probably recognize as soon as you see it, and you don't even have to do the work every time. But I think we should square both equations first. Am I allowed to do that? Am I allowed to square an equation?
Yes.
If x equals 4, is that the same as saying x squared equals 16? As long as you do it to both sides, that's a legal move, yes? So what if I square this equation and I make it x squared equals 9 cosine squared? All I'm doing is squaring it. If I square this one, I get y squared equals 3 sine squared. Just kidding. Nine sine squared. Oh, I've had too much. And now you're like, okay, where do I go from here? And so this is when people like to just get mad and say, well, this is dumb. But now you'll know how to do it. And honestly, it's where it comes from every time. Am I allowed to add two equations together? In second hour, they kind of went off their rockers for a little bit when I said that, because they're like, how do we add two equations? But you've been doing it since algebra 1. If I gave you this problem, don't write this down. In algebra 1, if I asked you to solve that, you could do elimination, and you might say, oh, if I subtract these two equations, then I could say that's negative y equals 3, right? You remember doing that? So you're allowed to do it. You just line them up and you add them together. You can do that with any equation. This one works out well because maybe you'll see where I'm going with this in a second. If I add this side together, do you agree that just becomes x squared plus y squared? It's the worst two ever. Yes. If I add this side, I get 9 cosine squared theta plus 9 sine squared theta. And remember what I'm trying to do here. I'm trying to get the theta to go out of the problem. I just want x's and y's. Can I do anything to this side right now? If I factor out a 9 from that, what am I left with? There's an example in your book like this, because I remember when I first did this problem, there's one on the homework similar to this. I was like, what am I supposed to do with this? And then I went and found the example in the book, and I was like, square both sides. Oh, genius, who would have thought that? Because sine squared plus cosine squared just equals 1, that's our Pythagorean identity, which means this is the same as saying x squared plus y squared equals 9. Now, who remembers what kind of graph that makes? When you have x squared and a y squared. I'll give you a hint. It's not a function. I'll give you another hint. It's a conic. I'll give you another hint. It's round.
Circle. You just said it's round.
The equation for a circle at the origin, if the center's at the origin, is just x squared plus y squared equals r squared. And it works out for a parametric equation. If they give you two equations where these are the same numbers and it's cosine and sine, it always gives you a circle. And so in second hour, they said, so if I saw a problem like this, I wouldn't even have to do all this work. I would just know it's a circle. with a radius of 3, because that's what happens there, right? That's 9. And I said, yeah, that works. Like, that's why once you do it once, or maybe a couple times on your homework, then you don't have to do all the work every time. But that's where it comes from. So this one, I said sketch it just so we could practice doing this. But if this was on your homework where it just said identify the graph, I want you to know that that's a circle. And if you were going to graph it, you just, the center is at 0, 0. And we're just going to go 3 all the way around, and we're going to try to make it look as much circle-ish as we can. So the other thing I want us to do today is work with the graphing calculator, and actually the first 4 questions on your homework are with the graphing calculator, but we're going to actually turn on the graphing calculators. I'm going to show you how to do this problem in the mode, because it's all about entering it correctly and making sure your window is correct to try to get this shape. And sometimes you just have to kind of play with the window and change the t values a lot on it. And then we're going to do the first 4 homework problems. Well, you're going to do them, and we're going to make sure that you get the right ones and see what goes in there. Step 1 is let's make sure your calculator works, because I have a big problem with it that doesn't work. And then I'm going to show you what to do on it. Some people use these already, so they might already be in the right mode. But let's see. So step 1, everyone turn it on so that as I pass them out, we will know if it works.
Mine doesn't.
You get mine. You're working up here. Anyone else? Everyone else's works? I know, don't look at mine. Here's what I want you to do. From this point out in Precalculus, we're going to change the mode in our calculator a lot. So it's really important that you always check this before you start graphing. If you go to mode, you can change a lot of things. First thing is you got to make sure you're in radian mode. Always in radian mode. We're talking about trig functions. Really should never be in radian mode in graphing calculators. So if you're not in radian mode, step 1 is go to that and just highlight it. And mine's already in parametric mode, and if you got someone's calculator from second hour, yours might be too. But normally we keep this in function mode. Function mode is y equals, because everything you graph in y equals is a function. So if you're not in function mode, you just arrow down to it. Sorry, not in parametric mode. PAR stands for parametric, and you hit enter. And then if you're in radian mode and you're in parametric mode, if you go to the y equals button, you should have an x1 and a y1, because for every parametric equation, you have 2 equations. And so go ahead and graph 3 cosine t and 3 sine of t. And I'll tell you, this button up here, the reason it's not just an x button, it's x, comma t, comma theta, comma n. So depending on what mode you're in, that's the button that you hit. So if you hit that button that we normally hit for x, it now says t, because you need a t when you're in parametric mode. The other thing we need to do is change our window. So once you get that typed in, go ahead and hit window, and I want you to kind of pay attention to what I'm saying about the window, and then you can kind of mess with your window as we go through these other problems. Sorry, I thought you had a question.
No, I do.
So when you're graphing trig stuff, your t value should be in terms of trig stuff. So my min and max is negative 2 pi to 2 pi. You might have to change that sometimes. Basically, you just mess with the t values and the x and the y values until you get the graph that you want to get. Yeah, yes. So then go to window. Pi's over above the caret, above the division sign. So if you type in negative 2 pi and 2 pi, you'll get this. This is the step. So this is like how many times you wanted to pick a t value. Usually the smaller the better. I don't know what this is, but try like pi over 8 or pi over 10 or something like that. I tried pi force and it changed my oval to an octagon, which is kind of cool. Watch. Pi over 4, enter. Not good, but so pi over 8. Nice and round. I said, sometimes you just have to mess with it. Now, I changed my max and min to -3 to 3 just because I knew it was already a circle. But on the ones from your homework, you might have to change it to other stuff. So you could change that just like before. That's your x minimum on your x-axis, your x maximum. That's your scale. Just leave it at 1. And then if you keep scrolling down, you have a y max or a y minimum and a y maximum. If you ever type something in here and it says error window, that means something's not typed in your window right. And so graphing calculators are great tools, but you've got to make sure you're typing stuff in correctly. So get that in, hit enter, and tell me who needs help. Oh, like to type it negative? Oh, are you typing it minus or negative? Because that might be the issue.
Okay.
You have to hit negative, not minus. That might be the
Okay.
You can't hit a minus button on there. Right, because if you're going to 2 pi to 2 pi, it's going to be 0. Like, there's no range there. So now it's 6. Oh yeah, see look, because I know it's a circle from 3 to 3, I just made my go -3 to 3. And then should fit on there beautifully, right? Anyone else need calculator help? Okay, so we're gonna grab a lot cooler ones on our homework. So let me give you the homework, and then let's start the first one together because it's really important that we enter stuff incorrectly. So, calculator, here's your homework. I think we only have 1 day of this. I really don't remember. This is not 5:30. This is 6:3. 1 through 4 we're going to do on the graphing calculator, which is why I'm giving you the rest of the time to work on the homework so that you can get their problems done. There's 4 graphs, which are super cool because they tell you what they're supposed to look like, and there's 4 equations, and you're going to type the equations in on your calculator to see if you can get that graph and all the crazy stuff that can happen. And then you're going to do 6 through 24 multiples of 3, 61, and 64. So everyone get that written down, and then get your book open and start typing in number 1 so that I can also start typing in number 1 so I can show you the correct way to type in, like, cubing cosine or squaring cosine. What here? Colton, where's your paper? Oh my goodness, children. Are we in pre-calculator class? We know pre-calculator.
I wrote mine. So calm down.
This terrible paper.
So calm down.
I have something to write, just like you like. It makes me happy.
Makes me sad.
Tim, does your hair look like that when you wake up, or you purposely make it look like that?
Well, when I'm here, I'm just like,
You do that a lot with your hair. I just wondered if it was like it seems like almost like you made it do that on purpose.
so you're saying it looks good?
I'm saying it's walking a fine line between bedhead and you style it that way.
Hey, that's kind of who I am.
All right, can I go back to the calculator part? I just want to point out that it's really important that you type this incorrectly, because number 1 says x equals 4 cosine cubed t, and y equals 2 sine cubed t. Remember, when you cube a trig function, you're cubing the whole thing, not just the t value. And so the number 1 reason that I should let you just type it in wrong so you can see the crazy graphs that you get, but I'm trying to save you some time here. If I'm going to type this in, I might have to change my window, but I'm just going to wait and see. If I'm going to type in cubing cosine, it's like, I guess I can't go off of this. Maybe this will help. It's like saying 4 times cosine of t cubed. But on your calculator, when you hit cosine, it automatically makes a parenthesis. So you have to really close 2 parentheses to cube that. Same thing as when you're squaring a trig function. If you don't put cosine in parentheses, it's going to square t, not cosine. So you're going to get 4 parenthesis cosine t, close the parenthesis, cube. With me on that? And then what's the other one? 2.
Where did you get the cube?
Isn't that a number 1 on, oh, Sorry. I hit caret and 3. I think there's a cube button somewhere, but caret gives you a power. So if you hit caret and then 3, that's raising it to the third power. That is easiest, I think. Mine's fancy, so it automatically puts the cube up there, but yours will say caret 3. And then 2 parentheses sine t parentheses caret 3. Answer. You can kind of already see my graph, but if you hit graph there, oh, does yours look like that? And if yours doesn't look like that, you've either entered it wrong or you need to go mess with your t-values or your window range and see what happens on that. So I just did number 1 for you. Number 1 should match up with letter B. And obviously when you get to number 4, you only have 1 left. But if you have time, you could try to type it in to see if you could get the graph. But those are some pretty cool graphs that would be really hard to do in function mode because you'd have to write an equation for each separate function. Like for this one, you'd have to write 4 equations to get this to graph. You'd have to write this equation, this equation, this equation, this equation, which is why parametric mode's kind of cool. And look at graph D is like an infinity sign. All right. And then when you're done with this, you can either give me back your calculator or you can put it in the box, and then the rest of them you should be able to do. Even if it says to use a graphing calculator, I want you to graph it by hand on the rest of this. Number 4 is like kind of crazy one, depending on what your t-values are. Like it kind of overlaps. So if you start your graph number 4, I think you should change your window to start at 0 instead of negative 2 pi, because otherwise it doesn't quite match up. But we can talk about that tomorrow. If you need to or do it. Well, I guess I could stop recording.